Okay, I'm sure we'll have a couple more people join us, but we have a fair bit of information to get through. And if people have questions at the end, we need to leave some time for that. My name is Jeremy Bide, and I'll be the MC for today. I won't say good morning or good evening because you have people from around the world today. But I will start off with a safety briefing, as we always do. Even though this is a virtual meeting, safety is still important. If you're in your webcam, please be in a safe place. If you're driving, we'd request you pull over and stop. Safety is very important. No distracted driving. Thank you very much. Okay, what are we doing today? Today is our demo day number 2. This is a follow-on from demo day number 1, which is a smaller event than today. They're linked, but if you didn't see demo day number 1, that's fine. Today will all make sense. What we're doing today is we're demonstrating the solutions offered by ourselves, AirMarket, by Astra, and by TELUS. We have 2 outcomes today that we're looking for. One, demonstrate how we both manage the airspace for the upcoming Energy UTM Trails. And 2, showcase our emerging products and services that empower enterprise drone programs at scale. That's our focus, enterprise drone programs at scale. We'll have to keep that in mind. Couple of housekeeping points before we get going. We have a large group. We have a large group today. We're pushing 40. I request everybody to hide your cameras and stay on mute. Save bandwidth, save distractions, save background noise. When you come to the Q&A, put your camera on, Ashley, so we can see who you are. That'll be easier. We'll have to work cooperatively to do the Q&A part because it'll be challenging. And also, please save your questions to the Q&A answers at the end. We have a dedicated spot. If it happens throughout with this large group, that'll be complicated. Also, if you're having trouble keeping the screen of the slides in the center of your screen, you can always pin it and unpin it if it changes to another presenter. It may come up automatically for you. Okay. Next thing I want to do is talk about our 2 major presenters today. We've got Lindsay Moore, who's the CEO of AirMarket, who is in Edmonton, Alberta. He's going to talk about FLYSAFE, a few other issues, but the context for the Canadian plans around the Energy UTM Trails. And he's joined by Ayhan Kamil from Dubai. He's the Chief Commercial Officer for Astra. We work very close to them, a great group of people, and he's going to give a specific introduction to the Astra UTM platform. So with no further ado, please, Lindsay, over to you.
I think, Jeremy, you were going to set the context for today?
Oh, of course. I'm moving ahead too far. Yeah, what are we doing here today? Let's talk about, I probably should not skip this. Let me be very clear, the context of everything that's going on, not just in terms of UTM or the trials, to effectively use drones for large operations, such as monitoring the pipeline network over a large area. You need to fly drones in large numbers. You need to be able to fly them beyond visual line of sight. We're not talking about one drone within visual line of sight. These are enterprise numbers, lots of drones, long distances. In order to do this, you need air traffic control for drones. That's unmanned traffic management, UTM, or in Canada, as we call it, RTM, RPAS traffic management. And to make this work effectively, what you need to have is a high level of affordable connectivity, not just connectivity, reliable, efficient, affordable connectivity. And once you've got unmanned traffic management, all this connectivity working together, it opens up a wider range of possibilities for remote and autonomous operations. That's what AirMarket and our partners are working on. That's why PTAC has been a major player participating in this with us, as well. Alberta Innovates has given us some support for this demonstration, for some ongoing work. And that's what the Energy UTM Trails is about. Using drones for a major problem, such as monitoring a wide area, enterprise level, beyond visual line of sight, connected. That's the challenge. So how did AirMarket come to this? AirMarket started with the development of the FLYSAFE SaaS product, software as a solution. It's a visual line of sight, VLOS, mission planning and compliance tool. It's also a fleet management tool. It's already been in use by Tech Resources, by Hydro-Québec. It's being adopted by the RCMP. We have other users as well. And it's the first step in a larger approach to drone operations. So things, from our point of view, start with FlySafe, with drone compliance, and expand from there. And that's the segue I appreciate made more effectively over to Lindsay.
Thanks, Jeremy. I appreciate the introduction. And folks, thanks for taking time out of your busy days and joining us on number 2 demo day here. So I want to talk about FlySafe. FlySafe is really an enterprise drone management platform that will ensure regulatory compliance in Canada. And it's how we, AirMarket, and our partners will manage our compliance throughout the trials. And if you boil it down from a regulatory perspective, there's an essential requirement to record your flight hours for your pilots and your aircraft. That's the bare bones requirements. Flowing on from that, though, however, there is subsequent requirements to track your maintenance, your incidents, and also perform site assessments, which is enabled with FlySafe. FlySafe is really intended to provide that single pane of glass to ensure regulatory compliance and help manage operational activities for an entire enterprise drone management program. And as you can see from the dashboard here, you can see a summary of all of your recent flights, the last 24, 30 days, 24 hours, 30 days, and last year. You have a summary, an understanding of your maintenance, what's scheduled, what's in progress, and what's been completed. You have an understanding of what you have for equipment, your drones, your batteries, your locations, but you'll also have a clear understanding of your personnel. Who is flying what, and what have they been doing over the last 90 days? Then lastly, you do have a incidents capability to record and track incidents, which is another requirement. In addition, though, the documentation facilities or documentation capabilities provide a rich way to manage your compliance requirements. We have checklists, risk assessments, and custom forms, along with basic documents that you can add to the system. And what's important to note is that you can assign these documents specifically against flights or pilots, and you can record their certifications, their pilot license. You can upload and manage your organizational documentation, including your systems manual, your operating manuals, and then lastly, your drone documents. So certification and registration for your specific drones. So what I want to talk about now is workflow. How do you use the system to plan and conduct operations? Well, it starts with a mission. A mission is essentially a placeholder. It establishes what are you planning to do. So this is pre-flight And so you can come in here and you can define the parameters of a planned mission. You can identify the drone that you want to use, the customers, the project, the location that you want to put in, and then the time when you plan to fly it. And we also have a placeholder for, in the future, UTM authorizations, which will be integrated with Astra, as you will see. One important piece here is you can identify the equipment on board, but the other important piece is your mission personnel. We also provide the capability to check people's availability. And so that's an important piece when you're scaling out an enterprise to be able to put the right people on the right job. The next piece that is important to understand is the flight area, the proposed mission area. We have the FLYSAFE map, which brings unique capabilities. We have data specifically purchased from NAV Canada. We update the aerodrome information every 56 days, and we also update the airspace data every 28 days as per the AIRAC cycle. And so you can see the flight area. We automatically assess the flight area for our proximity to airspaces. We also calculate the distances to airspaces and distances to aerodromes, and that gives the planners more advanced situational awareness for their proximity and the proposed risks that are associated with flying in that specific area. And so a flow on that we also allow them to plan the mission by providing dropping pins and providing hazard information around the specific proposed flight area. What flows on from that is the need to conduct a site assessment. And so we take all of that information from the mission, from the map, and we have a standardized pre-flight site assessment report that aligns with the Transport Canada requirements for site assessments. And so this is a PDF format that is a permanent record that would be attached to the mission and provide clarity to the pilot and to the managers of all the specifics around this particular flight, including maps, and also including the information around the potential flyaway buffer and the airspace intersections. We identify the contact information as provided from NAV Canada. And so that gives you a rich planning feature. And then the last thing that FLYSAFE enables is an approval. As you can see at the top here, this mission, you can implement an approval step here. And so depending on your organization and on your specific requirements, you can put in a mission approval. So the next thing that I want to talk about is, now that you have an approved mission, as we have here, as we're demonstrating, showcasing here, we have an approved mission. The next thing that you want to do once you have an approved mission is you want to go out and do the work. And then we want to be able to attach the log files to this mission and turn it into a flight. And so we have a very rich and robust parsing capability inside of FLYSAFE. We can interpret upwards to 40 plus types of log files. And we have automatic integrations with such platforms as DJI and Unique. And so you can see that there was 3 separate flights conducted here and were uploaded and added to this particular mission. And so what you end up with is now this is the specific flight, and you can see that the log file was interpreted and we've recorded it. And what that provides at the end of the day is a very rich, specific set of log files that is permanently recorded inside of FLYSAFE. So you know where the mission happened and specifically where that drone flew. And so that allows, that enables compliance assurance. And so lastly, what I wanted to talk about is our recent addition for functionality is notifications. We've added a capability within the system to allow administrators of the platform to automatically send notifications to pilots or personnel on the system. And so those can be triggered by certain events on flights, or you can send them en masse to the specific groups of people. For example, here, we wanted to make sure that everyone uploads their license to the system. And so we also allow and enable them to acknowledge the fact that they've read that, and that's recorded within the system. So I guess before handing it over to Ihan and asking him to introduce Astra, which is, I'll say, the sexy part of this demonstration, we want to draw attention to a couple facts that in the future, we will be integrating FLYSAFE and Astra. We'll be fusing the personnel and the drone fleets together. And that's all for two simple facts, is that we want to be able to facilitate airspace approvals. And Astra will be the system to be able to do those airspace approvals and gain those approvals from a wider range of airspace stakeholders. And then lastly, we will be automatically importing UTM tracking logs, as you will see here in the upcoming part of the presentation. So with that, I'll ask Ihan and his team to share their screen and present Astra and the capability overview approval workflow.
Excellent. Thank you very much, Lindsay. Hello, everyone. I'm Ihan. I represent Astra. Astra is, currently and has been for a few years now, the most advanced and capable UTM solution that exists globally. So what I'm going to do today is I'm going to walk you through and do a bit of demonstration of workflows and functionality that is relevant to the topic that we're presenting and addressing today. So what you're looking at on your screen right now is an operator's front-end access into the UTM system. So this is an operator logged into his mobile app to submit and identify a flight request. So what he's going to do there is he's simply going to identify where he wants to fly. So submit a few waypoints or the area that he intends to operate within. So here he's going to basically say, this is where I want to fly, this is where I want to operate within. The next thing he's going to do is set up the altitude, or say this is the ceiling, this is the limit that I'll go up to 108 meters. And then say, this is my start time, this is my end time, this is the time within which I'll be flying, sorry. And also identify the drone that he's going to fly with, whether it's a visual line of sight, whether it's a beyond visual line of sight. And also identify the purpose of the flight itself. So in this case, it is infrastructure inspection. So what the operator is doing, he's selecting the drone that is pre-linked, pre-registered to his particular profile, and also identifying that he's going to fly with a camera as well. So what the system is doing, it's prompting the operator, saying that there is a requirement for an operational risk assessment, which is JARA SORA, which we'll touch upon later on. And it's simply asking the operator to identify whether he has an associated risk assessment linked to the particular flight request that he's conducting. Here he says, yes, we'll touch upon the SORA requirements later on in the demonstration. So what's happening here is on the screen, you can see that we're identifying bits of information to the operator. So in this case, it's saying there is a safety score, there is a flight bill of $110, and there is an option to select insurance. So if you visualize that information and look at that in a bit more detail, so it's telling the pilot that there's a risk score of 6 for your total flight hours. There's pilot, permit category, and there's an NOC line of sight score. What the system is doing basically, it's identifying uh, based on the pre-configured rules that have been defined as part of the risk engine, which is a quantified approach to risk. It's identifying and basically calculating the risk associated with these elements as per the flight request parameters. What it's also doing is telling the operator that you're going to pay a flight fees of $110 for this particular flight, and which is based on the connectivity services. So he's roughly being charged a dollar per minute of connectivity, and he's also being charged $50 as a flat fees for this particular flight. There's also an option to integrate with third-party insurance providers who can provide on-the-go paper flight insurance, and the operator is free to select that and submit his request. So the system will now validate whether it's an approved flight based on the approved flight request, based on the rules set up by the various authorities and administrators. And the operator can review the status of each flight request. Here in this case, you can see that you have AirMarket admin that has already approved, so the flight request is pretty much approved based on their pre-input, pre-configured rules, what is acceptable to them in terms of parameters. So they set certain parameters about altitude that is acceptable, so flights being below 120 meters. And in this case, Lamont County and the AirMarket admin has set rules which this flight request is already complying with. And then you can see there is another approver, which is Department of National Defense. So the system enables multiple authorities to have a say as per their role in managing approving flight approvals, and they can set their rules on what to automate and what to keep manual. And if it is acceptable to AirMarket admin, for example, to allow flights which are BVLOS and which are sub 120 meters, the system will automatically approve those. And with DND, for example, it shows the operator that it's pending, the flight request is pending. And in this case, what we'll do now is we'll log into the portal side of things and review from an administrator perspective why this flight is, how they can process this, what's the status with the other authorities, and how they can approve this and review this flight. Just confirming.
Yeah, my screen's being shared. If you can pin my screen.
Yes, we've pinned it now. Okay, so on the screen is the flight request that we just submitted from the mobile app. As you can see, this is the request that came in from the operator. Based on the location and the jurisdiction set for multiple authorities and entities, you can see that it is supposed to be approved and reviewed by admin AirMarket, by Lamont County, and also by DND, who is accessing or who's logged into the system now. So what they're going to do is they're going to go in and review this particular flight. As you can see, there are a bunch of other flight requests there as well, which are, some of them have already been approved, and the blue ones, which are the ones that are pending. So this is how they would process it. They would look at the information which is consolidated for their benefit. You have the drone identified, which drone, which pilot, where, when, why, and for what purpose is this flight, and the status from the other two authorities as well. And here they can simply approve it, amend it, reject it based on what's acceptable to this particular authority, and they can process it as such. So now this approval has been processed. You can see the blue dot, which signified it's a pending application, is now green. So this is now an approved flight request by that particular operator, where they can now conduct the flight as per the submitted parameters. So to talk more about how we're going to leverage these capabilities, I'll pass it back to Lindsay, who will talk about how we're going to utilize these capabilities in Energy UTM Trials in Canada.
Yeah, thank you, Ihan. Great demonstration. So how are we going to be using this? Well, as you can see, this provides a very rich and robust way to manage, enable us to manage any type of volume of airspace. And it allows us to do it in a 4D dimension, time, lat, long, and altitude. And so it brings us the capability to onboard various different types of stakeholders, and that enables us to provide automated or manual approvals, all based on the parameters of the specific suggested flight. And so as we go through the approval process of the SFOC for the Energy UTM trials, we will use this to make sure that we address all of the requirements that get defined as part of that. And if you scale this up, you can see that there would be a full range of UTM services that can be provided here. And that's what we intended to do on a commercial perspective, is provide that approval and facilitate that approval processes on behalf of enterprises at scale. So that's how we're going to be using it. We'll provide a little bit more clarity around the flight aspect here in a subsequent part of the presentation. But what I want to provide is a little bit of clarity on how are we going to track the flights. And so around connectivity. And so can you see my screen? Is it visible, the connectivity model?
Yes.
Thank you. So we want to understand, how do we provide drone connectivity, cellular, how do we effectively enable cellular UTM services? And I want to talk about three specific things. So to begin with, Sky Data SIM. So we have been working for months with our strategic partners, TELUS. We are defining specific network services to enable UTM. We have identified designated and prioritized channels for traffic coming from drones. Those will have their own quality of service parameters specifically. And also working with TELUS and our partners, we are developing the capabilities of having coverage models. So integrating coverage model into the pre-flight mission planning is an objective that we have. We'll be able to provide real-time. We strive for providing real-time awareness of what's going on the network and what your activity will be in the proposed flight area. And so we're wrapping an assurance level around that. And then lastly, what this provides us is a connectivity framework. We'll have an API and integration framework available for others to extend and bring their capabilities to their systems. Next part is Sky Data Tracker. In collaboration with our friends at Astra, we have developed a drone agnostic 4G LTE solution that would be able to be installed or added to attached to any drone, and that would give real-time 4D positioning that you'll see in the upcoming demonstration. Next, as we hinted to in our last presentation, demo day, we have also built out Sky Data Link. It is a 4G LTE companion computer that is on the drone, and it's enabled to deliver computer vision. It also provides a framework for delivering command and control and streaming sensor data for beyond line of sight mission operations. And this is currently configured to work with open source flight controllers. And so this connectivity model provides the backbone for us inside of the Energy UTM trials and subsequent commercial services that we're bringing to the market to be able to provide that drone connectivity so we can understand where those drones are located. And so with that, I will ask Ihan to present his screen. And what as he's bringing that up, I want to provide a little bit of, stop presenting. There, I'll let you guys share, Ihan. I want to provide a little bit of context as they're bringing up their screen. So this demo, it represents how we plan to manage the airspace in the trials, but it actually extends a currently manual operational agreement that we already have in place with D&D, the Department of National Defense, and the 408 Squadron out of Namao. We have been flying our testing flights in this particular corridor for months now with support of TELUS. And so this actually demonstrates how we would like to go towards a automated or approval process in the future. And so this illustrates how airspace surveillance needs to be managed as part of the Energy UTM trials, and specifically around this CYA or Class F advisory airspace. And so this is also representative of many other potential airspace management use cases here that we will anticipate providing commercial UTM services for. So with that, Ihan, I ask you to go into the demo and provide clarity on how do we manage airspace and how do we deconflict manned aviation and unmanned aviation.
Sure. Thank you, Lindsay. So what we're going to demonstrate here is dynamic deconfliction. So for those of you unfamiliar with the term deconfliction, so there pretty much means to ensure that no two concurrent flights or flight activities in close proximity happening at the same time around the same place, you are able to resolve detect any conflict and then to resolve that. And so far, for deconfliction, there have been two ways of going about it. One is the strategic deconfliction, and the other being tactical or dynamic deconfliction. For strategic, what you do is you would separate them by time and by location. So you simply don't allow flights to happen at the same place at the same time. And when you do your flight approvals, kind of like NOTAM, where you segregate the airspace from any other sort of aerial activity. But given the advanced nature and the advanced capabilities and a lot of effort that has gone into Astra UTM, we are now able to deploy dynamic or tactical deconfliction, meaning that we can have simultaneous aerial activity, drones and perhaps manned low-flying air traffic operating at the same place at the same time, and still be able to kind of ensure that they're flying safely and there is no conflict or any incident in that sense. What this does and the end goal that it serves eventually is that you will have maximized airspace capacity utilization. You can have more aerial unmanned activity, given that it's sub 400 foot and below, 120 meters and below anyway. And as more and more drones start to fly and operate, we have a system that's capable and dynamic and advanced enough to basically enable operations at scale. So what you're looking at on your screen now, you're seeing two targets moving. There is an overlap between the two approved flight paths, flight areas. And as they move towards each other, which perhaps at some point they might intersect or be in really close proximity to each other, or have perhaps a similar altitude, which is not safe for each one of these operators, the system is going to detect the conflict at some point of time based on the pre-configured rules as part of the deconfliction engine, the parameters that can be configured to ensure what sort of minimum separation you are comfortable with whether it's horizontal or vertical. So you're going to see at some point of time the system, which is now detecting these as being in a state of conflict, and also not just detecting it, but also issuing a traffic advisory notification, a conflict resolution, in this case, which is decreasing the altitude by 55 meters for this particular operator. So as and when the operator actions this input, so he decreases his altitude, even though they are now closer to each other than they were earlier, you'll see that the system doesn't consider this as a flight risk anymore because it has ensured enough vertical separation between these two intersecting flight paths. So this separation, of course, like I mentioned, can be configured in the system depending on what regulation and what standard eventually will come into force for dynamic and tactical deconfliction. So perhaps to give a bit more perspective on what we just visualized here, we'll move to a 3D interface and get like a side-on elevation view on the flight tracks and review what just happened, basically. So you can see that, these two corridors are intersecting, and there was a good probability that these two flight paths would intersect at some point of time, which it did, and the system was able to resolve that. Just bear with me while we fix the angle on the screen. Yeah, so there was a TAN message that was issued to the drone operator here in this case, and there was, what we saw was that message was decreased by 55 meters. And you can visualize that there when the alert was generated, they were in a state of conflict, and this is the operator now dipping and changing the altitude, ensuring that there is at least 100-meter separation between the drone and the other low-flying aircraft. So what this ensures, in essence, is you can have multiple drones and low-flying air traffic operating at the same time, and you can have a system that can be configured as per the acceptable or applicable regulations and standards as they come along, to allow for increased capacity utilization without the need for strategically separating them, but having them dynamically operate, ensuring separation and safety measures are implemented as well. So again now to talk about how we're going to leverage these sort of capabilities in terms of deconfliction within the Energy UTM trials, I'll hand it over back to Lindsay to speak a bit more about the CAT 62 and Asterisk 62 integration with manned aviation as well. These are the aircraft you see in the background. Over to you, Lindsay.
Thanks, Ayhan. Great presentation. And what I forgot to mention, folks, up the leading part is this is a real example of what would happen in the Energy UTM trials. This could be a 408 D&D helicopter, or it could be a low-flying pipeline surveillance helicopter or Cessna that we will have to manage as part of the Energy UTM trials. And so this makes me quite, as a leader in the company, happy that we have a system that can do this and demonstrate this. So our plan is to leverage this, but also we have the connectivity services that provide the tracking of the drone that we talked about previously. That will take hours of flight operations to prove that system out. And that's why the Energy UTM trials are here. That's why we're proposing them, is we need to be able to fly hundreds of hours and to validate those capabilities. But also, what we also want to bring to the table is we want to integrate real-time manned aviation tracking feeds. We want to bring that into the system. And as Ayhan has alluded to, the system already consumes and supports the use of CAT 62 and Asterisk 62, which is international standards for surveillance radar. And so it already consumes that in Dubai and I believe in New Zealand as well. And so what we are planning to do as part of the trials is we are going to establish our own network of connected transponder surveillance hardware. So AirMarket will stand that up and establish connected surveillance network as the corridor grows. We'll start surveilling. The second aspect that we will want to do is negotiate with NAV Canada. NAV Canada has a very rich set of primary and secondary surveillance radar data feeds. And so that's part of the negotiations that we want to discuss as part of our application for the Energy UTM trials, and to bring this in and demonstrate how UTM can leverage conventional aviation data feeds. And then lastly, we can augment where needed with existing commercial airspace data feeds, such as FlightAware or something like that. So that's our plans for the Energy UTM trial. With that, I'll ask Ihan to talk about the Jarasora. The Jarasora is a international risk assessment framework, and we're going to use that to help define our special flight authorization certificate and gain our approval for the Energy UTM Trails to fly beyond line of sight. And so it's already baked into the platform, and I want to ask Ihan to share a little bit how that works already in the platform.
Thank you, Lindsay. So what we've done is, Jarasora basically means this is from the Joint Aviation Rulemaking Committee on Unmanned Systems under EASA, the European guys, and SORA refers to Specific Operations Risk Assessment. As you know, there are two categories within Europe: European regulations, open and specific, with a more stringent, demands on the operators if they are within the specific category as such. And SORA essentially looks at, they look at the ground risk and the air risk, and how they assess that, or how the guidelines that have been published. It's a very qualitative assessment of risk, and the elements that they rely on are basically the dimensions of your drone, how big or small it is, and then the population density of the airspace, under the airspace that you're flying over, and also the class of airspace you're flying over. What sort of other aerial traffic would you expect to encounter in your area of operation? So what we've done is we've taken all these guidelines and consolidated and converted them into a user-friendly interface, an operator-friendly interface, where if you essentially don't have a background in risk assessment, or don't understand risk assessment like the guidelines expect you to, you would simply do a step-by-step input of information, evaluate, identify various requirements as per the SORA guidelines. So what you essentially do is you define your ConOps, you identify your ground risk mitigation measures that you're taking, the air risk mitigation as well, and your tactical mitigation performance requirements as well. When you identify all of this, the system will basically essentially calculate a ground risk score and air risk score as well, and assign a SAIL level. So SAIL refers to specific assurance and integrity level. Assurance being that you would say that you have a capability in terms of an operational safety objective, which by the way are 24 as per the SORA guidelines, and integrity being that if you're capable, you will also do it. You're able to implement it, and you will implement it. The levels of requirement are low, medium, and high, meaning for each operational safety objective, you would say either make a claim, which is low, or provide evidence with documentation perhaps, which is medium, and if it's high, if the robustness requirement is high, then you need a third party or a competent authority to certify your claim or to back your claim. So all of this, when you consolidate it, you have a very a detailed and a thorough risk assessment that is tied into your flight application. So I'd link it back to the flight approval that we did on the mobile app at the very beginning. And the operator had already conducted this risk assessment for that particular operation in that location. And once it's approved by the competent authority, your risk assessment is approved, you are then cleared for operations in that sort of a scenario, that sort of an area, with that sort of a population density as well. So this is currently the only system that has SORA guidelines integrated and implemented within the UTM workflows. So again, how we can leverage this, specifically with AirMarket in Canada for the SFOC and approval work with Transport Canada, I'll pass it back to Lindsay to explain a bit more on that.
Yeah, thanks, Ihan. So I always bring it back to enterprise. How is enterprise going to use this and leverage this? Ihan hinted at it. It comes back to profile. So people's people's profiles on the system and providing enterprise a standardized way to be able to go and assess and gain approvals to fly BVLOS is all what this is engineered and designed to do. And that all flanges in together with the connectivity services that we're providing and the airspace surveillance capabilities. So it becomes a one-stop shop, a single pane of glass to be able to fly BVLOS and do it at scale. And so I'm going to share my screen one last time for Jeremy to guide us through this summary slide.
Thank you very much, Lindsay. So listen, in summary, there's been a lot of information quite quickly. We are a little bit over time. We could have talked for hours, but that would have been very dull. But in short, this whole architecture is to be validated in the Energy UTM trials coming up, which would then lead to limited commercial enterprise uses, which then lead to scaling up for widespread adoption. So that's where this overall system is going. In the interim, though, I want to be clear, FlySafe solution is available today. It's in use by, as I mentioned before, several major enterprises, and that the use is growing. ASTRA is in use today. It's been used in Dubai by the Dubai Civil Aviation Authority for, correct me if I'm wrong, this is the 4th year I think I had, and used in New Zealand, it's been trialed in Italy, etc. It's been well received. So those two are in the marketplace. The UTM connected connectivity services are under development right now. That's the dev work. And the overall system with other components is going to be validated and improved as we go forward. So that's the overall summary of where we are at today and where we are going. That's been 15 years. We finished 10 minutes earlier, but I would like to open up the floor for anybody for any questions. Nobody has any questions. Kate, you don't have any questions.
Hi, this is Craig Block-Hansen from Transport Canada. I have a few questions, but I want to give some folks a chance to ask their questions first.
Well, Craig, let's start with you. Just ask the first question. Let's break the ice. Go ahead.
Great. Okay, so I had a question around the FlySafe site assessment. Does the site assessment report include evaluations of the electromagnetic radiation environment, specifically for areas of potential interference when you're dealing with command and control links or potentially your DAA systems?
No, not currently, Craig. It doesn't. It would allow you to put a hazard on the map and allow you to self-assess it, but we don't assess it automatically currently. You
might actually need a separate tool as well. I mean, FlySafe comes with web and mobile apps as software tool, but you probably would need some hardware to do the test where you are.
Okay, great. I have a few more if everyone else is feeling shy.
Anybody else before you go back to Craig? Really? Okay, Craig, go ahead.
I have a couple questions around the Sky Data hardware. The Sky Data link, if I understood your presentation correctly, this is the transceiver that would be put on the aircraft. And the tracker itself, I'm just wondering as to the gross weight of that hardware module.
Yeah, to be honest, I haven't weighed this. I think it's about 60 to 70 grams, Craig, somewhere in that neighborhood.
And to refine to Craig, the whole issue of weight calories is the issue. As this goes through development, there's a continual push to reduce size Astra's got a lot of experience using trackers, and that they've had a lot of success in that field. So we're moving down that path as well. But you make a good point, but it's a key dev issue.
Okay, thank you. I have a handful more questions for on the Astra side.
Anybody else?
Alec with Coastal Drone. Hey, guys.
Hey, Alec. Good. Shoot.
So AirMarket, you guys are awesome. We love you guys. I have a question regarding platforms. So are you going to be recommending aircraft platforms that will work best with the system? Is there a minimum gross weight of a platform that will work best with your system? Is it better for bigger drones, better for smaller drones? That is there any type of specificity with the platform that you'd recommend?
I think our aim is to be platform agnostic. Depending how SkyD Link development goes, there may be issues around size, weight, and power. We're trying to keep it all possible to be platform agnostic. That is what the customer needs. That's their decision.
Okay. Do you foresee a minimum requirement though? Like, for example, if someone wanted to fly a DJI Mavic Mini and put this on a UTM, do you see there being some type of minimum weight or gross weight of an aircraft? I mean, there will be a physical capability if your payload is 60, 70 grams, but just because of the wide adoption of a Mavic Mini and it's blowing up like wildfire, I would imagine that a lot of people are going to try to get away with as much as they can.
Right, Jeremy, can I respond to that question?
Sure. Yeah.
Yeah.
Okay. So for that specific purpose, where DJI, we understand there's overall there's perhaps they're 85% of the retail market, and especially for platforms such as Spark and Mavic Minis, the mobile app that you saw, it's integrated or utilizes the flight control SDK from DJI itself. And so what we've done is we've embedded the same flight control interface as you find in the DJI Go 4 app. And the pilots, if they fly using the Astra mobile app, would not need to carry a transponder device, because the telemetry comes to your phone anyway. But if you're either flying directly with your phone or plugging your phone into a transmitter, we receive the telemetry anyway, and we've configured the app then to push the telemetry onwards to the UTM system. Therefore, ensuring compliance with the flight tracks as they come in. So even if the Mavics and the Sparks are aimed more at the hobbyist or recreational use, but if you plug them into kind of like an enterprise scenario, you can still track and monitor without the need for putting a tracking device. So it's a matter of having a flight control SDK available, which DJI has made available to third-party apps. And if it was a Parrot or a Unique, and if they have an SDK available, then you could simply embed that within the UTM app and not have the need to carry transponders. However, our lightest transponder is 28 grams, which is more than sufficient, or more, doesn't have a significant flight penalty on a Mavic or a Spark, just a minute or so.
Interesting. Thank you. That answers my question. Thanks very much.
Okay, Craig, do you want to ask your next question?
Sure. So this is a question for Astra, specifically with respect to its SORA model. Have you guys looked at the Canadian ORA tailoring of the JERA's SORA in our draft AC 903? We've identified a couple of differences between the JERA's EU version of the SORA and the Canadian risk environment.
Craig, it's Lindsay here. We're aware of those differences. We just haven't fully implemented them into the current tool set right now, but that's definitely on our roadmap to Canadianize the SORA and make sure we are in full alignment with Transport Canada's version.
Great, thanks, Lindsay. I do have a couple more questions.
Jeremy and Lindsay, it's Orest Warchola, Government of Alberta. First of all, an excellent presentation, Jeremy and Lindsay. Congratulations. It looks absolutely amazing. My question, Lindsay, to you is, with Unmanned Canada conference coming up in November of this year, have you given any thought to perhaps doing a presentation to the virtual conference delegates on the connected drone architecture and some of your plans for the UTM energy trials?
It's something we're considering. To be honest, we're buried into application detail and making sure that we cross the T's and dot the I's to get our application into transport and be successful in that. We haven't, to be honest, I haven't thought that much further ahead than the end of August, to be honest.
Yeah. Or if I can add this, I mean, it's something we have kind of talked about it, but we've got limited resources, a lot to do, and the RTMAT process is really significant. The integration work, development work is very significant. We need to get some stuff accomplished before we talk about it. We want to have some stuff done before we talk more broadly. This is only the second time we've done a demonstration like this, and this is the biggest group we've done it to so far. Should we do more? Yes, but it's a question of time, resources, and a bit of our approach.
Okay, copy that. Sounds good. Just wanted to congratulate you guys on your work so far. And if you do decide to do something on a broader scale for Unmanned Canada, there's still time to get into the speakers program should you decide.
Okay, thanks, Oris.
Thanks.
Any other questions? Craig, if you have more, feel free.
All right, thanks, folks. With respect to the ASTRA program, how does that tactical deconfliction system respond in the event of a network outage, like we saw in Ontario just this past week?
So that's a question more about operational procedures in terms of having loss of comms protocols in place with the operators that they comply with and that they follow. And it would simply be ensuring, if we have, for example, if the outage is something within our power, then to have backups in place and ensure some uptime from our side. But things that wouldn't be within an operator's control or within the, for example, something like network availability, then you would simply rely on protocols that would address those sort of scenarios. And again, that would be something for the regulators and the standard makers to put in place.
And Craig, I think that pulling back the onion, scaling back the onion, and getting clarity on what would have to happen, that would be all part of the work that needs to happen inside of the Energy UTM Trails or a project similar to that.
Certainly. Looking forward to seeing how that how these mitigations all kind of come together.
Are there any other questions for anybody else? We are at 1 o'clock. People are dropping off. We try and keep these things on time. Last call, Craig, if you have another question, we're happy to talk. Your points have been excellent.
I do have one more, but I imagine it's fairly similar to the one I had previously. It's a question on how DAA information integrates into the Astral platform. This is especially necessary in the event that non-participant aircraft are present when a tactical deconfliction presents an RA to the operator. So when that tactical deconfliction logic triggers and a resolution advisory is presented to the operator, how do we know, how does the Astral system consider DAA and non-participant aircraft that may be operating in that same environment?
Yes. So the logic there in the algorithm is you might have aircraft which aren't linked to your system, but as long as we're receiving that information either through, let's say, for example, secondary or primary surveillance radars, and we have that information available, we'd make it imperative on the drone in that case, drone operator in that case, to take the action without relying on the other target in question to let's say input an action or conduct an action in terms of resolving that conflict. However, yes, there is a need for let's say more enhanced low-level air traffic data that needs to be plugged into the system, where you would set up the deconfliction logic and extend it as such. Perhaps where let's say for example, if a low-flying helicopter isn't able to receive messages, something like a TCAS or a FLARM system, then we make it imperative as per the operational protocols for the drone operators to take evasive action, which kind of links to priority in the airspace. So the deconfliction engine already handles, for example, the implementation in Dubai, where you have a category where military gets the first preference priority without so if a TAN is issued, the military or someone, let's say for example state emergency services, they get higher priority and they're not bothered. Their flight tracks aren't disturbed or asked for any changes, but you would ask changes or deviation in flight path or a heading correction or an altitude change from the drone operator itself. Did that answer the question?
It did. Thank you very much.
Okay.
Any last questions? Ian, Lindsay, anything you'd like to add?
No, thank you folks for staying on the line and joining us today, and we really appreciate it. And thanks for all the questions. Ihan, anything with you closing?
That's it. I think we've covered all that was relevant to the topic today, and I thank you everyone for the opportunity to present to you guys, and we look forward to more engaging sessions on the topic, and especially the Energy UTM trials in Canada.
Thank you very much, everybody. Have a great day.
Thank you.
Thanks, folks.
Cheers.
Thanks very much, guys. Really good job.
Thank you.
Thank you. Bye.